This is just a quick video to remind us of a few things that we know about functions. Functions are a relation in which each input has exactly one output. So when we look at these function relations at the bottom, you'll notice the first graph or the first relation basically has each number traveling to exactly one other number. So it's like taking a machine, and if I inserted a 2, I'd get back a 6. If I inserted a 5, I'd get back a -1. If I inserted 7, goes to 2, 8 goes to 4. Each input or each member of the domain goes to exactly one member of the range. Now over here at the right, you'll notice that again, those inputs, again, what we often call the domain, right? This being the domain here, this being the domain there. These inputs don't go to exactly one place. When you insert 2, it travels to both 4 and 2, right? We don't travel to just one thing, we're traveling to two things, which means the second one would not be a function, right? Wouldn't be a function because the inputs in the domain doesn't necessarily match up with exactly one thing in the range. Again, over here. Now, in the real world, we could deal with these as well as in mathematics. So again, taking a good look at a few options here. The input, so let's say the domain where is a Shanley student, and the output is the activity that they're involved in. Would that represent a function? Well, what we want to think about is, can a student have more than one activity? And the problem we see there is, yeah, a student could be both in, track and field as well as football, as well as, who knows, maybe Shanley TV. The input is a Shanley student, the output is their first period class. Now, the problem on a schedule is you can't have more than one class scheduled at the same time. So, yes, that would be a function. No student can have more than one first hour class, right? No more than one class scheduled for that first period of the day. Mathematically, we want to look at our x values and our y values. Does every x value go to a y value? Now, it doesn't matter that notice all the y values on here are -1. As long as 2 went to one place, 2 isn't repeated for an x, or 3 is only in there one place for an x, each of those x values, 2, 3, 4, and 5, travels to exactly one y value, even though the y values repeat. I would say that yes, that's a perfectly good function. Looking at a graph, the easiest way to tell is what's called the vertical line test, right? We can use the vertical line test. Vertical. And remember, a vertical line has an equation of x equals. So to do a vertical line test, we're saying, well, if I drew a vertical line through my graph, could I ever have any one x value, right, that would travel to more than one y value? Well, if I draw that line here, I only hit that one green point. The problem is when we draw over here, now we've got a problem. At x is -2. Yes, we have two outputs. Therefore, according to the vertical line test, no, this will not be a function, right? Not going to be a function. The two equations look very similar, but again, we have to do a little bit of fancy work here. If we solved for y, let's say we took that x squared and we subtracted it over, y equals -x squared plus 1. Well, again, x squared, we're fairly familiar with that. That's going to form a quadratic equation. It's going to be a parabola. In fact, we're going to get a parabola that looks something like this. Well, would that pass a vertical line test? Well, it should, absolutely. For every x we input, we'll only get one y value back. Versus the equation over here for option F, if I add that x to the other side, 1 plus x, but now I take the square root. Well, remember, the downside to a square root is we have to say plus or minus. So for every x value we plug in, such as, let's say 0, right? If x were 0, 1 plus 0 is 1. The square root of 1 is 1. But remember, we'd get both a positive 1 and a -1, which means there's 2 points that have the same x value. There's an x value with two y values. Therefore, it would not pass the vertical line test. So again, when we're talking about functions, that's some of the stuff that we can talk about with functions. Every x value needs to correspond to exactly one y value. As long as we're talking about functions, we should talk about function notation. It's not a very tricky idea. Again, it's just a different way of writing. Instead of y equals, we write f of x equals, which means instead of f of -1, f of 0, f of smiley face, what we basically want to do is take out x in our equation and insert what's inside. So for each one of our functions, we're basically going to remove the x. We're going to have something squared minus 4 times something plus 2. And all I'm going to do is take what's inside, right? This would have been my x, and I'm going to plug it in for x. So again, we can do -1, we can do 0, we can even plug in these nice smiley faces, right? Move that right in there and over here. And the same thing goes when we talk about these expressions on the bottom. We can put in expressions as well. Instead of just x up top, f of x, now we have f of 3x. So take out x, plug in 3x. Or take out x, plug in x plus 3. Now we'd want to simplify. Again, up top, -1 squared is 1. -4 times -1 would give 4. And 1 plus 4 makes 5 plus 2 is 7. Those zeros make it pretty simple. 0 minus 0 plus 2 is just 2. There's not a whole lot we can do with the smiley faces, so really this is probably our best answer. But down here we do need to be a little bit careful. Remember, 3x squared, I need to square both the 3 and the x. So we're going to end up with a 9x squared. 4 times 3 would have been a minus 12x in the middle, plus 2. And again, since we don't know what x is, that's as accurate as we're going to be able to be. Same thing goes for f of x plus 3. Again, we can expand x plus 3 times x plus 3. And if you remember how to expand that, move that up just a little bit here. If you remember how to expand that, you'd get an x squared plus 6x plus 9. If you don't remember how to do that, you might want to ask your teacher on that one. Then we also want to distribute that -4x times both parts here. -4x and -12 come out there. And then finally, add up the like terms. We should end up with simply an x squared plus 2x minus 1. Again, there's just a few things we can do with functions. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.